Hello, I'm Robbie Clark. Welcome to my workshop. I wanted to talk about knurling tools. Knurling is something which I suppose most of us do at some point in our workshop as part of projects, even if it means making a knurling around a simple knob or handle for a tool in the workshop. When I've made quite a number of projects which I've shown before, where I've knurled locking knobs and locking screws on. This is my finger plate, and there's some knurling on all the locking screws on here and on the drill guide as well, just to make it easier to remove the drill guide in and out. A tool I made a long time ago is a cross drilling attachment for my Myford lathe. This block replaces the tool holder on the lathe, and enables you to cross drill through material. And all the knobs on here, I made all of these, and they're all nailed. There's a couple of steel ones and one made out of brass. Also on this is the tool height adjustment jig, and the two brass locking knobs on here have knurling on them as well. The tool that I use for all of these is one I guess you're all familiar with. It's a scissor type knurling tool. I bought this a few years ago, and you mount this in the tool holder on the lathe, and then you can adjust these scissor arms down to the material. And you've got obviously your two revolving wheels. These are purely to give you a sort of diamond shape on these particular wheels. The only problem I had with this is that the arm on this is actually too big to go in the Dixon type tool holders I have, and I did think, well, what I could do is just machine the diameter of this down, but in the end I opted not to do that. And a simple way of fitting it into the tool holder was to use a little vise which can be mounted into the tool holder, locked in place. Means you can slide this in and out as well, lock in place, and then the knurling tool can be clamped in here. I know it's a bit of a sort of a complicated setup, but I had used this for cross drilling jig as well. The idea for using a vise here wasn't mine. It was another YouTuber, Steve Jordan, who used an identical setup to this for a cross drilling attachment, and of course it does work perfectly well with the knurling tool. When I bought my Chinese mini lathe, this was bought second hand, it had a whole box full of various accessories that came with it, and it came with this knurling tool. Well, I guess you're familiar with this. I call this a sort of a jog knurling tool. This fits into the tool holder and is pushed against the work. This part swivels so that it will find its position very easily. To be honest, I've never used this. When I was doing some research a long time back on knurling, a lot of people said that these aren't an ideal thing to use on a lightweight lathe, particularly my Chinese lathe, and really even the Myford lathe, because this can put a lot of strain on the spindle of the lathe, and on the bearings. My Myford lathe has very heavy duty bearings. I didn't want the possibility of damaging it, so I must admit I've never used this one. Although this one did have a much larger shank here, which I actually did machine down so that it would fit the holder, just in case at some point I did take the risk and actually use it. Both the knurling tools here will only give me diamond patterns anyway, but I wanted to try straight knurling as well. And with straight knurling, you actually only really need to have one wheel, really. And I did buy this device. It was quite inexpensive to buy, and it is only a steel shaft with one knurling wheel, and that of course fits into the tool holder in exactly the same way. And I have used this a few times, but not with a lot of success. I found the only material I could get a reasonable knurl on with this was aluminium. Still, if any, it seemed to push the tool away rather than it cut a knurl. So again, I sort of really gave up on the idea of using that. But fairly recently, I was very, very lucky to get hold of another type of knurling tool. I'm going to bring the camera a little bit closer so I can show you this in a bit more detail. Bear with me just for a moment. Now, this is the knurling tool that I was lucky to get quite recently. It's made by a company called Index. A bit of research on this. I believe this was possibly made in Germany, because there is a German manufacturer of engineering equipment called Index. The other reason I thought it came from Germany is that originally all the locking screws on it were actually German made, but I have replaced all of these because the original ones that were in this were quite badly damaged. So I've replaced them with Allen head screws, which will actually make it a lot easier to lock and adjust. This works in an entirely different way to these knurling tools, which generally would be held in the tool holder. This one is probably designed really more, I guess, for production use in possibly a turret lathe. And this, I guess, would be mounted into the turret. It's, if anything, a lot more difficult to set up, because the holders here for the knurling wheels, they're mounted into slots, so these can be moved in and out, and you've got locks on here to lock them in position. And if you lock them and undo them and tighten them just slightly, you can use this screw here to adjust them in, and if we just push them into place. The knurling wheels, the same as these knurling tools, the knurling wheels can be replaced, and they can be adjusted to give you either a straight knurl or a diamond knurl, and that's done by releasing these locks here and rotating this part round. At the moment, I've got it set with a fairly fine knurling wheel to give me a straight knurl, but if I slacken these off and then turn them round to a 45-degree position, both of them, then I will get a diamond shaped knurl. You won't be able to see this, but there is actually an index mark here on the holders and on the holder of the wheel, and an additional one here marked for 45 degrees. That can be brought round to that position. I have got in total 4 sets of knurling wheels for these, ranging from a very, very fine to very coarse. And I've already experimented a little bit with this with the 2 middle wheels. Now this could be mounted onto the tool post if you made a suitable adapter for it to mount this onto the tool post itself. But I thought using it that way, I'd run into similar problems that I have with this one, in that if I'm knurling fairly hard material, as you draw this along the material, it has a tendency to twist. And no matter how tight I mount the quick change tool post, it always seems to move. And I thought this would possibly do exactly the same thing if I mounted it that way. So what I decided to do was to mount this onto the tailstock quill, so I can use the quill to push this along the work. Now, the limitations to this in terms of diameter of material is the diameter that you have here. If you can see that, the diameter of the hole here, and going back to about here, there's a much smaller diameter through this arbor at the back. At the moment, it's got a sort of a blocking screw in the end, but that is the minimum or maximum rather size of material that you could knurl by moving the material right through, and that would be the maximum of material you could draw up to this position. If you wanted to knurl larger diameter material, you'd be limited to the distance from here to the face here. There is another threaded hole on the top. This is to take an anti-rotation bar, but the way I've actually devised to mount this onto the quill of the lathe tailstock, this so far has not rotated at all. So what I made was this adapter. The arbor will fit into here and then can be locked in with these 2 Allen head screws, and on the back side here, this can be mounted onto the tailstock quill. It only has a lock on one side. On this side there's a grub screw which ends in a dog point here, and that locates in the keyway on the quill. So that will actually stop that from rotating, and if you lock these in, these won't rotate either. Now, to stop any damage to the arbor, although you see in its past it has suffered some wounds to it, all the Allen screws here, I've drilled the fronts of them out. You probably won't be able to see that, but it has little brass inserts in all of these so that it won't actually damage the arbor here. Not that I guess it's going to make too much damage to it. There's any sort of real worries there at all. I have obviously seen these before, and one of the YouTubers that's shown one of these quite a number of times is Mr. Pete Tubalcane. The one he has, or he has a number of them, are made by I think a now defunct American company called Brown and Sharp, and it's basically identical to this one. I mean, I suppose a number of manufacturers probably made knurling tools like this. He did a video, or several videos, where he's shown parts being knurled. And on a recent video where he showed this again, he did say that he would show you actually how to set the knurling tool up for a piece of round bar, But unfortunately, during the video, he neglected to do that. And I was rather hoping he would, because that would have sort of really helped me. But I was able to get some advice on this from another YouTuber, viewer, subscriber, and friend that gave me a lot of useful tips on how I can actually set this up. So what I'm going to do is to set this up on my Myford lathe and show you how I have worked out how to set the tool up and actually do some knurling with it. I've only done a few experiments so far on some fairly small diameter aluminium. I don't know if you can see this. This was of the two middle-sized knurling wheels, the larger of the two, to give me a straight knurl and a diamond knurl. It came out quite nice. And the wheel that's on here, the second finest wheel, again to give me a straight knurl and a diamond knurl. So again, bearing with me, and we'll set this up on the lathe and see if I can hopefully demonstrate to you how this could be set up. I mean, it's obviously quite an old knurling tool, but it is, it is actually beautifully made, and this must have been a colossally expensive item when it was new. It has all sorts of numbered codings on here and the index name on here. I suppose that's their own logo. The knurling wheels are quite easy to replace. You just unscrew the holder here and then just gently tap the pin through and then replace the knurling wheels for various other sizes. And as I say, I've got 4 different sizes of knurling tool for it, but I guess there are other sizes available as well. I suppose the size of knurls you can produce are quite endless, actually. But anyway, let's set this up on the lathe and see if I can demonstrate to you how the tool is actually used. Okay, ready to set up to use the new knurling tool. I've already placed some material in the chuck here, and I've faced off the end, and I've turned down the diameter here because the material obviously isn't sort of perfectly round, so I want to sort of have a perfect round piece of stock, ready to knurl on. The material I'm using, it's a 3/4 inch aluminium type 6082T6. It's a new material to me. I haven't used this type of aluminium before, but I gather it's a very, very high quality turning material, and certainly the finish I've got on it is absolutely wonderful. It's really beautiful. Now, to use the knurling tool, the setup obviously is completely different to using a scissor type knurler, where the knurling wheels can be placed over the top of the material and then adjusted inwards, and also adjusted during the knurling process, even while the material's revolving as well, to give you the depth of knurl that you want. With this tool, you can't do it that way. You need to set the knurling wheels in the correct position to give you the depth of knurl that you want straight away. I mean, it is possible to make a readjustment to it, but I imagine that this knurling tool was designed I guess more for production use, where once the knurling tool is actually set up, a whole production run can be carried out, and the tool for knurling doesn't need to be adjusted again. So what I'm going to do to start is you really need a sort of a lead-in for the knurling wheels. So I'm going to machine a small undercut at the front here. Doesn't need, I don't think it needs to be particularly deep, probably about 3/16 of an inch deep. And from the tests I've previously done, about a 20,000th cut. Anyway, I'll do that first, and then we'll look at the process of actually setting up the knurling tool. Now, before I set the knurling tool up, what I'm going to do straight away is change the belt speed to the lowest it will run. The lathe will run without using back gears. Just move the belt across. The lathe then was running at about 670 RPM, and with the belt changed to the lowest, it runs at about 233 revolutions. And just move the carriage back a bit. There we go. Now, as I explained earlier, I made an adapter to enable me to fit the knurling tool to the quill of the tailstock, and it's got a locking screw on one side and an Allen screw on the opposite side with a dog point, which will locate into the keyway of the quill. Just lock that into position. So with that locked in there, nothing should twist here at all. And I can insert the knurling tool. Let's lock that in. So it's in quite solidly now. Now I guess this is the sort of the most difficult part of setting this up. Actually adjusting the knurling wheels to give you the right depth straight away. I had some advice from another YouTube follower and subscriber to my channel, but there's no sort of information out there. Obviously, there's no instructions with this knurling tool, so it's by a little bit of experimentation already. I've sort of tried to work out, possibly the best way of doing this. So if you bring the knurling tool up to the workpiece, and then slacken off the locking screws are slackened off pretty well, and then draw them both in against the undercut that I've already made, and hold those in. But also doing is adjusting or screwing in the adjustment screws to touch the back of this part inside here, so that if I do need to make a further adjustment, that gives me, if you like, sort of like a starting point. And we'll lock those into position. So hopefully that's going to be enough to give me a reasonable depth of cut. As I say, it is possible to adjust it further, but it's not as easy to do that as it is with the scissor type, because when you adjust the scissor type, both of the knurling wheels move in together. With this one, you're adjusting each wheel independently, so you've got to try and adjust them separately, but in equal movements, basically. I mean, I think what would probably help on this knurling tool would be to have a calibration on the top here and onto the tool here, so that you've got some sort of indexing point. That only in my opinion, but I think that sort of possibly could help. Let's just hope I've got enough there to give me a decent knurl. I think I'm going to adjust those in just a little bit more from sort of previous experimentation. I think that actually did help. So we slacken these off and then just lightly tighten, and then just move those adjustment screws in just a little bit further on both sides. I want to do it about the same amount on each side. And then lock those in. The Allen key here, I had to sort of cut part of the end of it off because I discovered that there was a bit of a restriction in area to work in here. So this sort of helps to get the Allen key in better. I mean, hopefully that's going to be enough. But time will tell. Okay, let's move that back now. I'm going to move the knurling tool forward so that I've not got to use a huge amount of movement on the quill to adjust that in. So hopefully I've got that set up okay, the knurl itself. Now I'm going to use WD-40 as a lubricant, and spray plenty of it on, plenty onto the knurling wheels and to the workpiece as well. So let's see how we get on. Okay, the moment of truth. And actually that appears to have worked pretty well. I don't know how well you can see that, but obviously I will take the workpiece out and bring it a bit nearer to the camera so you can see. But it's given quite a nice nail. Obviously you can't use that section at the front here where you machine the sort of the lead in, so the length of nail you've got, obviously you've got to plan that out to exactly what you want. And setting up for knurling, obviously it depends very much what the knurling is being used for. If this was a knurling on perhaps a locking screw, I guess the ideal thing to do would be to turn down a front section here so you can machine down and cut the thread on the locking screw itself, and then do the knurling afterwards. But so it depends exactly how and what it's going to be used for. The part at the back here, obviously, there's probably enough there that could be chamfered off, or perhaps a section here could be turned down slightly to give you a bit of offset shape to it. So either could be done on that. What I will do is I'll just literally chamfer the front of that, because you've got obviously a lot of sharp ragged edge to that at the moment. To move that knurling tool back out the way. I won't bother to sort of reset the belt speed. I mean, as I'm just going to do a chamfer, it's not actually really going to matter too much that it's running at a sort of a low speed at the moment, really. But I've put quite a big chamfer on that just to get rid of that sort of ragged edge. But I think that, to me, that looks absolutely fine. Let's remove that from the chuck so that I can show you. If you can see that okay, that under the light. But that's given a very, very nice nail. Now I think that overall, comparing this one to a scissor type knurling tool, not to say that I've been using the scissor type for quite a number of years. I mean, I've only had this one for a short time, sort of month or something like that, and I've only really getting to the point of actually starting to use it so far, just really for testing to learn how to use it. But as I'd mentioned before, with the scissor type knurling tool, what I found was that when it's set up over the material and you're moving the knurling tool across, as you are doing here, across the work, that the knurling tool had a bit of a tendency to slip to one side. And what I found, although the nails did look perfectly fine and I was more than happy with them, the actual pattern of the nail wasn't if you like, square to the material. So if you probably not the best see this really well, but if you look at the lines of the knurl itself, they are all perfectly straight and perfectly in line around this way as well. So to my mind, this one does give you a much better quality knurl overall compared to what I was getting with the scissor type. The scissor type one, I guess if anything, was much easier to set up. This is obviously a bit more work involved in it, but I think if I sort of, obviously do some more practice and experimenting with it, I can work out what sort of undercut to give on the material for the various different sizes of knurling wheels. Obviously, when you're doing a project and making a part which needs a knurl, you don't want to have to sort of keep doing sort of test and retest every time. Really, it would be nice that you could just go straight ahead and cut the knurl immediately. But as I said, that this tool almost certainly is made for production purposes, probably on a turret lathe, where all the various operations are carried out, and then the knurling tools brought in to make the knurl, and probably producing dozens of parts, I guess. So you only really would need to set this up once at the very beginning of the process, and carry on from there. Anyway, we'll perhaps go back to the bench and sort of have another look at the knurling tool and sort of talk a little bit more about it. Before we go back to the bench for a bit more discussion, I decided to do another knurl on a larger piece of material. It's the same type, 6082, but this is 1.25 inches in diameter, and it's possibly about the largest size that you could comfortably knurl with this tool, because it's about as far as the wheels would extend out, and possibly just a fraction larger, but this is actually probably the largest material I've got available to do it with anyway. So I'm going to do the same thing again, make a little undercut here. I'm not going to change the knurling tools. I thought perhaps I should change the knurling tools up to the largest size I've got, but I think this probably will look quite nice with the same size of knurl on it. I think that it will look fine. So let's turn that down for an undercut here first. Okay. I did have a look at the previous bit of knurling I did, and I do apologise that my head kept getting under the camera there. I'm trying a new camera position, having the camera mounted right above the lathe. I mean, I've not done this before, but it seemed to be about the only position I could put the camera so that you could see all of the operations. I had tried having the camera at sort of like an oblique angle, but if it wasn't me getting in the way, it was something else getting in the way of what I was doing. So apologies again for my head being in the picture. So back in with it, the knurling tool again. Also, if you hear any loud banging in the background, it's one of my neighbours having some building work done. I'm hoping that these new microphones I'm using will sort of cancel all of that out. I think they actually do. So process again, bringing the knurling tool in, and you see that with those right out, there's not a huge amount of room left. And we guess it. Is it possible? Might take a bit more. I guess it's possible. It might. I don't know. It might go up to. Well, not quite an inch and a half, but sort of fairly near to that. So again, if I bring those knurling wheels in, and then bring the adjusters in again, adjusting screws, bring them in, and then we'll lock those off. And what I'm going to do is make that adjustment the same as before. Bring the locks in and move them back just slightly. And that back again slightly, and then adjust that out a little bit, and then adjust the wheels in a little bit more. On both sides. And we'll lock that off. Okay, and I've got to just drop the belt speed down again. Okay, I think we're ready to go again. Some more WD-40. Okay, let's see how we go. And again, I think it's given us a nice knurl again. Yep, that looks fine. Obviously, that first part where we made the undercut, you obviously not going to be able to use. It's obviously quite ragged, but that could be turned back, as I stated before, perhaps to give you a little step in here, and then the top part of it chamfered off. But again, it's it's dependent really on what the end result's for. So there we are. So I'm glad I tried a larger piece. I mean, I've only used this knurling tool, I suppose, 3 or 4 times, just as an experimentation prior to doing this, and I've certainly not knurled a piece of material this large. Obviously, I had to cut the bar down quite short because the problem with the lathe here, this is a Myford ML7R, and it has a very small hole through the lathe. It's through the lathe spindle itself. So you're also limited by the size of the hole in the lathe chuck, and how far you can bring the jaws out. Obviously, for an 1.5 inch and a quarter material, that was no problem for these jaws. I mean, this chuck is not one that originally came with the Myford lathe. It had Pratt Bernard 100mm 3-jaw chuck and a 4-jaw 6-inch independent chuck. This is one I bought just a few years ago. I wanted a 4-jaw scroll chuck. And this one's a really nice one. I found this on eBay. It's made by TOS, a Czechoslovakian company, and it was already mounted on a backplate suitable for the Myford, but it only came with the inside jaws, so no outside jaws with it. It's probably why it was being sold at a reasonable price. So I mean, I do have limitations on the diameter of material I can turn on this. Obviously, anything bigger I can use the Myford Pratt Bernard chuck, because I've got inside and outside jaws for that. But yeah, I got a bit sidetracked there. Sorry. Anyway, if I bring this a bit nearer to the camera, I hope you can see that okay. It's given me a very, very nice knurl pattern, and all perfectly straight in both directions. And when I've not chamfered this off, so you might be able to see the sort of where the undercut was. It's obviously a bit ragged there, but that looks really nice. So I'm very pleased that it's turned out that well. Okay, so we now will go to the bench and just have a sort of a bit of wind-up discussion on the knurling tool. Before we wind up the video, I'd already made a drawing here of the tool, just to give you some measurements, if it's of interest to you. Primarily to show you the size of material that could be knurled. By bringing both of the knurling wheels and their mounts right out between the two knurling wheels, you've got a maximum diameter of material of about 32 millimeters. But the depth of knurl would be controlled by the edge of the knurling wheel here, and when the material would come up against the body of the knurling tool. So you've only got about 20 millimeters of available knurling length there on that size of material. Obviously slightly better with slightly smaller material. There are two inside diameters to the knurling tool body. The first section is 25 millimeters wide, but that's a tight 25 mm diameter. So I guess if you were knurling material, you'd have to make sure that the material is less than 25 millimeters in diameter, because once you start knurling, the knurling tool will obviously expand the diameter of the material, and it could jam inside. So you've got the maximum diameter of 25 mil overall, and the length of this hole here is 32 millimeters. So that coupled with 20 here, you would have about a sort of a 50 millimeter length possible to knurl into the tool itself. The part of the knurling tool that goes into the shaft at the back of the tool here is 15 millimeters wide. But as the shaft here is open at this end, of course, there would really be no limit to the length of material. Again, you'd have to make sure the material is less than 15 millimeters in diameter to pass through here. But you could, if you needed to, knurl a very long piece of quite small diameter material. Measuring this up, everything on here seems to be metric. The knurling wheels are 20 millimeter diameter wheels, normally supplied, although the wheels that I've got on here were actually adapted for me. They are, I think, about 19 mil diameter, or sort of 3/4 of an inch diameter. They had to be machined so they would fit the mount. So the wheels are, I think it was about 6 millimeters or so wide. That gives you, a basic idea of what the capabilities of the knurling tool are. Well, I hope the video's been of interest. And my little schematic here as well. So I've obviously turned these two bits of material here, the 3/4 inch diameter and the 1.25 inch diameter. Before I finish with the lathe, I just machine the end of it here as well. Just put a step in here and put some chamfers on the edges as well. Not quite sure what I'm going to use this for now, just perhaps keep it as a sample. I mean, that bit of metal might be useful for something else. I think I actually have an idea of what I might use this part for. But the end result, the knurls were very, very nice indeed. And from the bit of experimenting I did beforehand, where I did make sort of a couple of other experiments with material as well, just to sort of work out how to set the knurling tool up by having that little undercut at the front to establish the depth of knurl that I wanted. So there we are. I think we can sort of draw this to a conclusion now. I mean, I hope I've explained everything as accurately as I possibly can, but this is, I mean, it is a super tool, and well, I guess it is quite old, and I could imagine it's had a lot of use in its lifetime. But bearing in mind, I'm sure that compared to the scissor type knurling tool that I've got, and I don't know what they cost now. When I bought it, it was, I think, was around about £20–25. This must have been a colossally expensive item compared, and I'm very, very pleased with it. I'm very happy to have this tool. It's going to give me a better option for doing sort of nice knurls as well. And as I mentioned, I've got overall 4 sets of knurling wheels for it, so I can do very, very fine knurls either in diamond patterns or straight knurls, just by revolving the wheel mounts around, just slacking off the screws on either side and just rotate them round. Anyway, thank you very much for joining me in the workshop again. Again, thank you very much to all the subscribers to the channel, and to all the nice comments I'm receiving as well. And I hope to have another video for you very, very soon. So thanks very much. Bye bye for now.